In this example, we will talk about logistic regression, try to apply it to data sets and interpret the results in these data sets. And the source of the data is from University of California, LA. And here is the data source. Let me write in here. And it has 4 variables. They are called admit, GRE score, GPA, and rank of their undergrad school. And the aim in here is that we are going to build a model so that the predicted probability of that student getting admit if we are given his or her profile in here. Let's first read the data in here, and we can read CSV because it's a CSV file and directly from the website. And so maybe first thing I do in R that I want to see the first 6 lines of the data. We have admit, GRE, GPA, rank. Admit is going to be our response variable, which are 0 and 1. It shows if that student is admitted to the University of California, LA, or not. Okay. For example, for the 4th person, and this person GRE is 640 and GPA is 3.90, and the rank of this students, what was that? Undergrad school was 4, and that means they are just giving the grad school administration scores. And with this scores, this person is admitted to school. Okay. And if you want to get more idea about the data sets, you may just check out the structure with SDR. And you see that we have 4 observations of 4 variables. And admit, GRE, and rank is integer, and the GPA is numeric. And in this data set, there are a greater number of rejects than there are acceptance, since the mean of variable admit is less than 0.5. And maybe it's a good idea to change this rank to factor. And let's say we will change our rank variable because it's more like a factor, and use it as a factor in our analysis in here. DF rank and okay. And when we say summary of DF, you will see that this is the admission, which just sees as integer in here. We have the summary statistics for GRE, GPA, and admit, and also for rank. You see the frequencies for rank in here. And in R, if you want to fit a GLM, you can just do it as the same as linear model, except using GLM instead of LM function. And also you may need to specify the type of GLM to fit using the family argument in your comment. And so we already convert our rank variable to factor. And when we just use GLM, we can say that admit is our response variable. We want to model it versus our GRE plus GPA plus rank in this example. And you should define the data set, which is DF. And also we may want to give the family as binomial to make sure that we are just running a logistic regression in here. And let's give it a name as logit. Here is my logistic function. And if you want to see the summary, you can just write summary logits. And here are the output for our model in here. And you can see the model one more time. And the first one is the deviance residuals, and we have coefficients, and we want to talk about them. And so logistic regression has some advantages over classification methods such as KNN. And after doing some predictions similar to the KNN, you can do inferences different than the classification methods. This is a very good advantage for logistic regression because it allows us to do some inferences about the model and the data sets. So, for example, we can say that each 1 unit increase in GRE, by looking at the estimation of this GRE, we can just say that each 1 unit change in GRE will increase the log odds of getting admit by 0.002. And it is p-value, you see that the p-value in here indicates that it is somewhat significant in determining the admit, okay? And we can do a similar interpretation for GPA, but the interpretation of rank is kind of different because it is a factor, and so we can say that rank is going to the rank 2 college from rank 1 college will decrease the log odds because it's negative, getting admit by 0.67. So going from rank 2 to rank 3 will decrease it by minus 1.34. Okay, and now this is how we are doing the interpretation for factor variables. It is just showing the difference from going from one category to another one. And this is how we are doing the interpretation about the estimations in here, which is kind of important for us. And after that, we see null deviance in here, which is the value when you only have intercepts in your equation with no variables. And residual deviance is the value when you are taking all the variables into account. And greater the difference, better the model. When you have the greater the difference in here, your model is better. So it makes sense to consider the model good if that difference is big enough. And to get the exponential coefficients, you may tell R that you want an exponent, which is exp, and that the object you want the exponent is called coefficients, and it's part of logit. Let's say what I mean in here. Okay. We have x function in R. We can use it to get coefficients of logits. Okay, this is our model we already defined here, and we are just checking coefficients. You see, here are more coefficients, and I want to see exponentiates of them, and you see them now. For a 1 unit increase in GPA in here, let's say it's as an example, the odds of being admitted to graduate school versus not being admitted increase by a factor of 2.23, okay? And so we can also do some predictions, and predictions can be done for new or unseen data sets we haven't used here. And so we can start by calculating the predicted probability of admission at each value of rank, holding GRE and GPA at their means. So first create and weave the data frame like that. Let's generate a data frame. Here is my new data 1. And I need my DF. And I want to add a data frame in here. And GRE is going to be the mean of GRE. Let's just keep it like that. And GPA is the mean of the GPA variable. And rank equals factor from 1 to 4. Okay, this is our new data sets. When you run that, you will see that you have this GRE, GPA, and these are the mean values. That's why they are all the same. and we have rank from 1 to 3 and 4. And we can just check out for these data sets how it is changing. So new data 1, rank P, okay. We are just adding the prediction from our model, logic model, by using new data as new data 1 that we define already, and type is response. We are looking for the prediction of response in here, and here is my new data 1. Okay. Now, by looking at these variables, we are trying to find these predictions. The predicted probability of being accepted into a graduate program is 0.52, this one, for students from the highest prestige undergraduate institutions. They are ranked as number 1. And for it is 0.18 for students from the lowest ranked institutions, holding GRE and GPA at their means in these examples. Now in this video, we have seen these data sets from University of California, LA, and their administration to grad schools. And they just recorded GRE, GPA, and rank of the students undergraduate school. And we were able to just check out the predictions depending on this model to admission. And also we were able to do some predictions for our new data sets in here.